right, and welcome back from your holidays. Hopefully you've all had a really restful break and you're ready and rejuvenated and ready to go for Unit 2. Okay, so we just finished up permutations and combinations before the break, and now we're going to jump into our next topic, which, as it says on the screen, is matrices. So you may or may not have seen these little guys before. They're a really helpful tool in mathematics, computer science, anywhere where you need to organize a lot of data. Matrices are really helpful. Okay, so we'll jump right into it. Again, I'm sorry I can't be here today with production. I'll be away for a couple of days in the next week or two, but then after that I will be around for sure. So what is this matrix thing? Not the movie, but it is an array of numbers in rows and columns used to organize data as well as other applications. One particular application I kind of mentioned very briefly in passing when we looked at solving linear systems. We can use these matrices to help us solve linear systems. We'll take a look at that a little bit later. They can help with networks, flows, graph theory. They're really helpful tools. So that's what a matrix is. A couple of definitions that go along, and then I'll show you what a picture of one is. So within a matrix we have entries, which is, so n entry is a particular value in a matrix. So as I said, a matrix is an array of numbers. Each of the numbers that we put in, we call an entry. Okay, so it's any particular value. Also, a couple of little noteworthy things. All right, so just going to give you a couple little conventions. So our first little convention is the idea that we generally label matrices with capital letters. So much like we did when we were labeling events in probability, so let A represent drawing an ace, okay? Same idea, we label matrices, so instead of having to rewrite the matrix all the time, we give it a name that we can refer to. Okay, we use capital letters to refer to a matrix. Okay? Whereas, again, these are conventions. We generally label the entries. Okay, so that's each particular number within a particular matrix with the corresponding lowercase letter. And coordinates. There you go. Okay. So for each matrix, I might call it A. The entries inside I will refer to with little letters, so the lowercase letters, with basically an ordered pair to refer to where that entry is in the matrix. Okay. Now this point, I think, deserves to be in red. It's very important. So the next point is that the location of an entry is always row, then column. So row always goes first. So like we have x, y coordinates, x is always first and then y. Here we have the row and then the column, always in that order. So let's draw up a little example here. Okay, so let's get something. All right, so let's draw a lovely little picture of what one looks like. So for example, I'm going to call this one A, because A is the first letter in the alphabet, and that's generally what we start with. It's made up of numbers in rows and columns. Okay, again, this horizontal is a row, vertical is a column, So always organized in rows and columns, so it's very neat and tidy. Okay, so in general, so the one I drew there is a particular example of a matrix made up with the first row 1 and 2, second row 3 and 4, and the third row 5 and 6. Okay, but in general, to use this notation I just talked about, okay, so the very first entry would be lowercase a 1 1. Okay, the next entry down, that's in row 2, so it will be 2, still in column 1 though, 1. A 3 1. The pattern continues for as many rows as you need. Here I'm still in row 1, but I'm now in column 2, and then row 2, column 2, row 3, column 2. I'll maybe do one more just to emphasize. Row 1, column 3, row 2, column 3, and row 3, column 3. Okay. You can also, some textbooks use round brackets to enclose matrices, but I will always use square, and that's what the CAS will use as well. So let's get into doing a couple of examples. Alrighty, so there's our example there. So example 1, I'll give you a minute to write it down. For the matrix A, which is going across the first row, 2, -7, 3, second row, 3, 8, and 5. Just getting used to using the notation, I'd like you to state what's the value in A23, what is the location of the number -7, and what is the value in location A22. Okay. So we'll talk a little bit more about how matrices have to be organized in just a minute, talking about the order and the dimension. But here, again, just getting used to the notation. Sorry about that. So, for part A, what we're looking at here is using basically these as ordered pairs. So think of it as, okay, row 2, column 3. Again, row is always first, so I go to the second row, the third value, 1, 2, 3. So the value 5 is in location A23. So A23 is equal to 5. Now B, we want to find, it's working the opposite way, this -7. What's its location? So I start, because the matrix is labeled capital A, we're going to use a lowercase a, again, always corresponding lowercase letter to what you've named the matrix. And it's in the first row, so it's going to be 1, and it's in the second column, so 2. And then part B, the value in A22. So what that's really saying is A22. Okay. A meaning it's in matrix A, 2 meaning row 2, other 2, column 2, row 2, column 2. Sitting right there, we've got the value of 8. Okay. So that's just getting used to using some of the notation. So again, capital letters to label the matrix, lowercase labels to label the entries, and then always putting a little location. Okay. So again, I mentioned we've got one more definition, which is order. Okay, so getting into the particularities about how we talk about matrices, we need to be very particular with our terminology. So what we've got there is a good old definition for order. So what order actually means, it's the dimensions. So the dimensions of a matrix given as row by columns. In general, the letters we use M to represent the number of rows and N to represent the number of columns. And that's pretty standard across the board. Again, next year in year 12, you use the same notation. So order, think of it as the size. Okay, how big is the matrix? We give it basically the length times width, rows by columns. Now, when we're talking about this order, we need to be able to identify it by looking at the matrix. And also, if you ever want to enter one of these in the CAS, it's going to ask you for the dimensions so that you can just fill it in. It will basically create a template for you. We'll take a look at that in 2 seconds. So it's really important you're able to identify the order of a matrix by looking at it. It becomes even more important later when we get to doing operations with them. So here's another example for us. So example 2, I would like you to find the order of the matrices below. So we'll do 3 examples of a variety of different matrices and go from there. So the first one I'll just draw out for you by hand. So I'm just going to fill with random numbers, so 1, 2, 3, and 4. B. Let's give these names and be proper. So B, 1, 2, and C, 1, 2, 3, 4, 5, 6. Okay. So when we look at a matrix, always think rows first, columns second. So the dimensions, again, really important when we get into matrix multiplication, but also if you ever want to enter them into the CAS, you need to be able to identify it. So the number of rows in this one row, 2 rows, by the number of columns, also 2 columns. Now for part B, often when we have just either just a column or just a row, we call them vectors. Okay, that's just your fun fact for the day. Here, all we're looking to do is identify the order. And again, counting how many rows do I have? 2 rows, but just a single column. And last but not least, okay, 2 rows and 3 columns. Okay? They're not always 2 by something. You can have pretty much any dimension you would like, making them as large or small. Again, for really complicated data analysis, one big application is Google's search engine. How they organize how to link from one page to another is done through a matrix. You can imagine how many web pages there are on the internet. Their matrices certainly aren't 2 by 3. They'd be millions by millions. There's another fun fact of the day for you. And just to finish up with matrices, the CAS. Okay, again, this course I'm really emphasizing getting comfortable with the CAS so that next year you're happy to use it. So the CAS can be helpful to allow us to work with matrices. You know, in a non-CAS exam, you have to know how to work with them by hand, but really, really helpful to just be able to enter them on the CAS. So for today, all we want to be able to do is enter a matrix. On Tuesday, we'll get into adding, subtracting, and doing other operations with them, but for now, I just want you to be able to put a matrix on the CAS and save it as a variable. Okay? So I'll write out the steps first, and then we'll go through how to actually do it. So steps. Step 1, you need to open a calculator page. We should all be semi-professionals at this, whether it's in a new document or a homework document you have going, add a calculator page. That's document type 1. Within this calculator page, you are going to press the template button. Now I'm going to do a sorry attempt at drawing a picture of this, but again, we'll go through on the screen how to do it. It's a little button, it's got a line, a box, a line, set notation bracket, box, and box. So that's what your template button looks like. Oops. So continuing on from here, we press the template button. It's going to bring up a little menu. What you're going to do within that menu is use the arrow keys to scroll over, sorry, it kind of overlaps there, to the desired size. So there are some default ones, 1x2, 2x1, 2x2, but once you get beyond just the basic ones, you do have to select basically the default one, and from there fill in your order. Okay. So for anything bigger than 2x2, okay, select the one that looks like 3x3. So this one that looks like 3x3 is basically your anything other than the default ones you're given. What you're going to do then is enter the order in the pop-up menu. And we'll go through a couple examples in just a minute. So you open this template, it brings up a menu, scroll over to the size you want. You may need to select the other option and then fill in your order. Okay. Then what you're going to do is press Control Variable. Okay. This is going to give you a little arrow. Okay, this arrow allows you to define variables and store them under that name. So if you want to refer to that matrix again, you don't have to go up and copy it down. It's saved as the name A, whatever you've given it. Okay, and then you're going to use the keypad to give it a name. Okay. Here's another kind of fun fact for the day. If you accidentally pick the wrong size, you can use the return carriage symbol. So this is just beside your keyboard at the very bottom. Oop. And Shift plus that button to add extra rows and columns respectively. So if you just press the return carriage button, that will add another row, or if you do Shift and then the return carriage button, that will add another column. So let's go through a few examples of getting used to doing it on the CAS. Okay, so what we're going to do, get your CAS out, turn it on, open a new document, open up a calculator page, and just get organized. All right, so example 3 is store the matrices from example 2 on the CAS. Again, today we're not doing much with them, we're just entering them and storing them on the CAS. So let's scroll back up to what our example 2 questions were. So the first one was A, it was 2x2 and had the values 1, 2, 3, and 4. So here's my CAS. I've opened up a calculator page, so step 1 done. Now, this button here, so if you find delete, just below delete, it's on the left side. Okay, so mine's currently highlighted in red. That is your template button. So notice in the second row, you've got 4 buttons for the matrices, 2x2, 1x2, and 2x1, and then just that other. In this case, I've got a 2x2, so let's just do that. Mine is being something a bit funny is happening with my program right now, so let's give it a second. There we go. 1, I like to press tab to move in between the values, 3 and 4. So that actually creates the matrix, okay? But I want to be able to refer to this matrix all over the place. So instead of having to constantly retype it, I'm going to store it as the name A. So again, pressing Control and then this variable button, so just above the number 9, it gives me that arrow. So control, variable, gives me that arrow, and then I use my keypad at the bottom. I'm calling it A. I know it goes against convention, but the CAS will not store capital letters. It will always just change them back to lowercase. So even if I store this as capital A, notice it automatically switches it back to lowercase a. Now, if I want to type the letter A, notice it goes bold, and when I press enter, it calls up that matrix. So now I can do all sorts of fun things with it, like multiply it by 2. And we'll get into what actually happens, but you'll notice it just multiplies each entry by 2. Now the next one, okay, was a 2 by 1 matrix with values 1 and 2. Let's go back, hit the template button. In this case, it's right there, so I can click on it. Okay. Storing the values 1, 2. You can use the arrow keys or tab to move between, and control a variable. That one I'm calling B. Okay. Now when I press B, it's stored. Okay, and then the last one, I notice I go to template. I don't have, okay, so here I'm looking for a 2 by 3. Notice there isn't a default 2 by 3 template, so I go to this 3 by 3. Now it asks me how many rows and columns, so it's asking me for the order. I want a 2 by 3. I click OK. I have just stored the values 1, 2, 3, 4, 5, and 6. Being too creative there. And control variable, and I'm calling it C. So our goal for today is to be able to refer to entries of a matrix, be able to talk about and identify the order, and then finally be able to store them in the CAS. So just getting you comfortable, a little bit of an introduction to matrices. Tomorrow we'll get right into operating with them. So that's all for today. If you have any questions, again, stop by my office. I am at school today, so we'll be there at lunch. Thanks.